One method for solving quadratic equations is to use square roots. At the top, we have 3 examples of very simple quadratic equations that can be solved using square roots. So x squared equals 81. We have only one operation being performed to x. We are squaring it. So the inverse operation here is just square rooting both sides of the equation. That leaves us with a solution to the equation of not just 9, but also -9. If I plug in 9 for x, I get 9 times 9 is 81. But -9 squared is -9 times -9, which is also 81. So there are 2 solutions to this quadratic equation. This case, same inverse operation, we just square root, but there is only one square root of 0. 0 times 0 is 0. The no solution case here is when I take the square root of both sides and I find myself taking the square root of a negative number. There is no number that times itself equals a negative that you know of in Algebra 1. So 9 times 9 is positive 81. -9 times -9 is positive 81. And if we were to do 9 times -9, which we would need to get to -81, that would not be squaring one value of x. Usually, our quadratic equations are not quite so easy. The first thing we would need to do is isolate the quadratic expression on one side of the equation using inverse operations. So in other words, just kind of pretending that this is an x, we perform the same inverse operations we would do to solve the equation 3x plus 1 equals 76. If we think about our flowchart idea, we square x, multiply it by 3, then add 1. Working backwards with inverse operations, we first undo that addition. So we have 3x squared equals 75. Next thing to undo is the multiplication by 3, so we divide by 3, which gives us x squared equals 25. And now we're to the simple quadratic equation case where to find the solution, we just square root both sides of the equation. There are 2 solutions, not just 5, but also -5. Really important to get full credit that you write both of those solutions. Checking our work, 5 squared is 25, times 3 is 75, plus 1 is 76. Check. -5 squared, where of course that -5 is in parentheses. -5 squared is 25, times 3 is 75, plus 1 is 76. Kind of a different case here is where we don't just have an x squared, but we have an expression squared. That's okay, an expression squared. To undo it, we can still just square root both sides of the equation. So the square root of anything squared is just that original quantity or expression. So x plus 3 parentheses squared, and then take the square root. That just leaves us with x plus 3. So we're undoing that squaring by taking the square root of both sides. Now, this gives us a simple one-step equation, x plus 3 equals 10. But the important point here is that x plus 3 is not just equal to 10. X plus 3 is equal to plus or minus 10, since there are 2 square roots to that 100. 10 times 10 is 100, and -10 times -10 is 100. That means I'd have actually not just one, but 2 equations. In this case, I need to solve 2 one-step equations, x plus 3 equals 10 and x plus 3 equals -10. That gives me 2 solutions, x equals 7 and x equals -13. Again, this takes into account the fact that whatever's inside the parentheses can equal 10, so that when I square it, I get 100. Or what's inside the parentheses can equal -10, so that when I square it, I get 100. And indeed, 7 plus 3 is 10. 10 squared is 100. -13 plus 3 is -10. -10 squared is 100. Looking at some other examples, this one is just like my first example when I add 8 to both sides. I get 2x squared equals 32. Dividing by 2, I get x squared equals 16. Make sure that you show that inverse operation of square rooting on both sides of the equation, and do not forget to write both solutions. Sometimes it will be the case that you will not end up with x squared equaling a perfect square. So after I subtract 2, I have 3x squared equals 150. When I divide 150 by 3, I get 50. 50 is not a perfect square. My solution is therefore x equals plus or minus the square root of 50. I could have written this as plus or minus 5, plus or minus 9. But that is not my fully simplified form. There's a reason we learned how to simplify radicals. The square root of 50 is the square root of 25 times 2, which can be simplified to square root of 25, which is 5, times the square root of 2, 5 radical 2. So the solution to this quadratic equation is plus or minus 5 radical 2, which I'm totally fine if you write as 5 radical 2, negative 5 radical 2. That really highlights the fact that there are two solutions to this equation. These other two examples require you to perform inverse operations to isolate that squared expression. So before you do anything, you divide by 2. And now we're to our second example case where we have an expression squared equals 49. Again, when we take the square root of both sides, we end up with just that expression inside the parentheses, x plus 2. But then we have two possible solutions, 7 or negative 7. This is the most common missed point on the quadratic equations test. Students only solve this one equation, x plus 2 equals 7. They forget to find the negative solution case where x plus 2 equals negative 7. So my two solutions to this quadratic equation are x equals 5 and x equals negative 9. If I plug that in here, 5 plus 2 gives me 7. 7 squared is 49, and 49 times 2 is 98. Plugging in negative 9 plus 2 is negative 7, so that gives me my negative 7 case. Negative 9 plus 2, negative 7. Negative 7 times negative 7 is positive 49. Positive 49 times 2 is indeed 98. This last example is just requiring me to perform an extra inverse operation. Again, just pretending this is an x and getting it by itself. Never, ever, ever forgetting that I have two possible square roots of 9. Two equations, x minus 1 equals 3, x minus 1 equals negative 3. So x can equal 4, or x can equal negative 2. Again, what I want to get in here is 3, or negative 3, so that when I square it, I get 9. So 4 minus 1 is positive 3. Positive 3 squared is 9. 9 times 3 is 27. 27 plus 1 is 28. But also, I could have negative 2, because negative 2 minus 1 gives me negative 3. And that's the other way that I can get 3 here, or negative 3 squared. So negative 2 minus 1 is negative 3. Negative 3 times negative 3 is positive 9. Positive 9 times 3 is 27. And 27 plus 1 is 28.